Hello everyone, I am Dr. Krishna Sarker. Here in this session, I will be going to discuss about Mason's gain formula. This is signal flow graphs, lecture series on linear control systems and lecture number 28. So our topics Mason's gain formula. What is Mason's gain formula? Mason's gain formula is a method for finding the transfer function of a linear signal flow graph. The formula was derived by Samuel Jefferson Mason. Transfer function or gain of a given signal flow graph can be easily obtained by Mason's gain formula. So this is our actual transfer function or gain of a given signal flow graph can be easily obtained by using Mason's gain formula. The relation between the input variable and the output variable of a signal flow graph is given by the net gain between the input and output nodes and is known as overall gain of the system. Mason's gain formula provides a step-by-step method to obtain the transfer function. This is also important. Mason's gain formula provides step-by-step method to obtain the transfer function for a signal flow graph. This method can easily handle signal flow graphs with many variables and loops, with inner loops. It is a technique used for finding the transfer function of a control system. So finally, it is a technique. Mason's gain is a technique. Actually, Mason's gain is a technique used for finding the transfer function of a control systems. So that's why this is the very important topics. Mason's gain formula determine the transfer function, overall transfer function or gain. That means determine the transfer function, overall transfer function or gain of signal flow graphs, and as per the formula, the overall transfer function is, this is the formula for Mason's gain formula, overall transfer function CS by R of S, where C of S equals to output or Laplace transform of output. This is the effect of the systems, and reference input. This reference input may be step, ramp, parabolic impulse, any type of input. And this is equivalent to what? Summation of k equals to 1 to k, pk del k by delta, pk del k by delta. And pk, put k equals to 1, 2, 3, 4, put k equals to 1, 2, 3, dot, dot, dot. Then we get P1 del 1 plus P2 del 2 plus P3 del 3 plus P4 del 4. When k equals to k, then Pk del k by delta. This is the Mason's gain formula or overall transmittance or gain, where output variable C of S and input variable R of S. R of S also called excitation, and this is also cause and this is effect. CS is called effect. So Mason's gain formula CS by RS equals to summation k equals to k pk del k by delta. Mason's gain formula, where from this formula delta equals to what? This is the delta. delta is determinant of the graph. Delta equals to 1 minus sum of gains of individual loops plus sum of gain products of possible combination of two non-touching loops minus sum of gain products of all possible combination of three non-touching loops. This is the delta. This is the delta. Sum of gain of individual loops and sum of gain products of possible combination of two non-touching loops. Similarly, three non-touching loop product of all possible combination of 3, next term 4, next term 5, dot, 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 n product of all possible combination of up to n product of non-touching loops. So what is delta again? Delta equals to L1. This is the sum of gain of individual loops. Suppose loop number 1, L1, this is L2, this is L3, dot, 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 Ln. That means n number loops. Then second case, plus sum of gain products of possible combination of two non-touching loops. Suppose L1, L2 non-touching, L2, L3 non-touching, dot, 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 Ln minus 1 Ln non-touching. Then minus sum of gain product of all possible combination of three non-touching loop. Suppose L1, L2 and L3 are non-touching, L2, L3, L4 non-touching, plus dot, 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 L3, L4, L5 also non-touching. This is plus. This is plus. Similarly, next term L1, L2, L3, L4, L2, L3, L4, L5, dot, 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 dot. This is the delta. This is the delta. Similarly, again, delta equals to 1 minus summation of LA plus summation of LB plus summation minus summation of LC plus dot, 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 plus minus 1 to the power m minus 1 to the power m summation Lm, where Lm equals to what? Lm equals to product of the loop gain of any m non-touching loop. Suppose m equals to 2, 3, 4, 5, 6, 7, 8, 9, dot, 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 n number. Product of the loop gains of any m non-touching loops. So this is the delta. Then from transfer function, this is the transfer function. And what is k? What is k? K equals to number of forward path between input and output node. Between input and output node. K equals to number of forward path between input and output nodes. Similarly, pk. This is the p of pk. Pk equals to gain of the kth forward path. Pk equals to gain of the kth forward path. And del k equals to, del k is the cofactor of pk. And delta k is obtained from delta of the full graph by eliminating all terms involving loops that touch the kth forward path. So primary information, this k equals to number of forward path between input and output node. Similarly, pk equals to gain of the kth forward path, gain of the kth forward path, and delta k is the cofactor of pk. Delta k is obtained from delta. And next case, delta k equals to delta minus. What is the formula of delta k? Delta k, this is the delta k. Delta k equals to delta minus summation of loop gain terms in delta that touch the kth forward path. This is the delta k. Thank you.